Let's start it. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, meet again in the financial data analytic class. And for tonight's session, we are going to discuss on financial data analytics using decision tree analysis. What is the objectives that I want you to have for your competence for tonight class is that you understand what is machine learning, type of machine learning, problem in machine learning, and what is decision tree in machine learning. And then what kind of problems that decision tree solves. The advantages of decision tree, disadvantages of decision tree, and some demo. So as you know, there are three types of machine learning. There are supervised learning, unsupervised learning, and reinforcement learning. Decision tree is within the supervised learning. Decision tree. Why we put decision tree in the supervised learning? Because in decision tree we have dependent variables. Yeah. Dependent variables. Why? For the dependence and X for the independence. So we put it as the supervised learning. So what kind of supervised learning that decision tree solve? Decision tree solve the problem of classification, where the problem can be using the categorical solutions like yes or no, true or false, 1 or 0. Yeah. Decision tree solves the classification problems. Decision tree can also solve regression problems, where the value using the continuous value, to be predicted. So in the classification, there are four kind of modeling that can be used. There are naive Bayes model, logistic regression model, random forest model, and decision tree model. Our topic for tonight is regarding the decision tree model. So what is decision tree? Decision tree is a tree-shaped diagram. Tree-shaped diagram used to determine a course of action. Each branch of the tree represents a possible decision, occurrence, or reaction. So, like this, when there is vegetable, we would like to know the capsicum. What is capsicum? The capsicum. Yeah? So the capsicum color is red. Is the fruit that you pick is red or not? If it is false, or true? Okay, if it is true, there will be chili and capsicum. Okay. What about the diameter? If it is more than 2, we think it is true, capsicum. If it is false, then it is chili. So, which one is capsicum? This one. So this is the simple example on how to identify a vegetable from a shopping bag. So basically, the problems that decision tree can solve is classification and regression. A classification tree will determine a set of logical if-then conditions to classify a problem. So in this classification, we need to discriminating between types of products or condition based on the certain features. And also decision tree can solve regression problem. Regression tree is used when the target variable is numerical or continuous in nature. Yeah. So basically, we can do also both using classification and regression. That is what we call CAR tree. Classification and regression tree model. Yeah, the CART. What are the advantages of decision tree? Decision tree is simple to understand, to interpret, and visualize. Very simple. It consumes little effort for data preparation, and decision tree can also handle both numerical and categorical, hybrid or mix between categorical and numerical. And non-linear parameters do not affect its performance. So there are several advantages that we can have by using decision tree modeling. Also, there is disadvantages of decision tree. What are those disadvantages? First is the overfitting occurs when the algorithm captures noise in the data. So that becoming overfitting. And also a high complicated decision tree tend to have a low bias, which make it difficult for the model to work with the new data. Low
Excuse
bias.
me, Panjari.
Yes, Sebendu.
What is overfitting?
Overfitting. Okay. So when there is noise in the data, yeah, overfitting. When you wear a t-shirt, yeah, the data compressed, like too much compressed on you. That is overfitting. So too much compressed on you. So what is the, how do I describe it? Okay, let's come back to the, let me see, overfitting. Yeah, I would like to see the definition, clear definition for you. Overfitting in data. Very slow. Okay. Okay, overfitting is a concept in data science which occurs when a statistical model fits exactly against its training data. When this happens, the algorithm unfortunately cannot perform accurately against unseen data, defeating its purpose. What causes the overfitting? Overfitting occurs when the model has a high variance. This one. Example, if the model performs well on the training, yeah, in the training data, the model performs okay, but does not perform accurately in the testing, yeah, testing data. The model memorize the data pattern in the training, but fail to generalize the unseen examples. So when it in the training data, the model perform accurately, but when going into the testing data, the model there is the testing the testing data towards the training, there is only small not lesser accuracy, less accuracy compared to the training data. Do you see what I mean, Bendu?
But meaning that overfitting purpose is only like, okay, it is like it is only good when it is being tested, but when it comes to real ground application, the
Yes.
results are good, something like that.
Yeah, the accuracy is not as good as in the training data. Let's say in the training, when you say you are true or good or bad, so the accuracy is around 90% for good and bad in the training data. And then when you put the data towards the testing, you put the training data towards the model, the accuracy getting lower, around 70%. Do you see what I mean? So we have 100 data. Okay, let me explain this in the PowerPoint. Okay. 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 So we have 100 data. We split it into 70 for training, 30 for testing. So actually we already have the data here, the good and bad. Which one is good, which one is bad, and this one is, we already know the good and bad. So in the first 70 data, we have accuracy around, the model gain accuracy around 80% accuracy. But when the testing data, this is the training. But in the testing data, the accuracy getting lower, around 70%. So there is overfitting in the data. Araso, Bendu.
So training, it is meaning like means it is at the very initial, it is mean the dummy quantity, or it is also the actual data for what we are talking in the training and
the 100 data is the actual data. The 100, let's say you do the binary logistic, yeah. Binary logistic. Okay. In the binary logistic, there will be buy or no buy. Okay. You have 100 data, they buy and no buy. And then you develop the binary logistic model. And then when you develop the binary logistic model, the accuracy of the model, the y equal to 1 plus 1 plus exponential c plus beta x blah blah blah, the 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 model that you develop gain 80% of accuracy. From 70 customer, around 56 people gain accurate output. Buy, you predict buy and actually they buy. You predict not buy, actually they no buy, around 80%. But then you put it into the testing data. When it come to the testing data, only 70% buy and 30% no buy. I'm sorry, only 70% is accurate, 30% is not accurate. Meaning you predict buy, but actually they not buy. So when the accuracy in the training data gain higher percentage compared to the testing, it is overfitting in the data.
Okay.
Araso?
Understood.
Okay, good.
Sorry, Pak Jerry, can
Yes,
you
Giselle.
repeat the last sentence that you mentioned, Pak, on the conclusion of overfitting?
So when you have better percentage of accuracy in the training data compared to the testing data, meaning there is overfitting in the data. Supposedly when the training data 80%, testing data supposedly also 80%. But since there is overfitting in the data, the training data be getting higher accuracy compared to the testing data.
Even though the level of percentage is 80.
The level of percentage of the training data is 80%, but the testing data gaining lower than that, 60k, 70k.
No, like just now,
Supposedly,
in case the training.
Supposedly from the 100 data, you are randomly put 70-30, yeah? Randomly. Supposedly, when it is 80% accuracy, this one also 80% accuracy, isn't it? Because this is randomly selected.
Yeah.
But because there is overfitting, when you segregate the 70 getting 80%, the 30 getting 60%. Why? Because there is overfitting in the data. Araso, Giselle.
Okay, yeah, thank you, Pak Jerry.
Okay, good. All right. Okay. Okay, so let's continue to the decision tree. What is a decision tree? Decision tree is a decision support tool that uses like a tree like, but upside down, yeah. The tree going up, the decision tree going down. So this is the upside down tree. Yeah. The decision tree is a tree like but upside down. A tree like model of decision, yeah, and their possible consequences, including chance event, outcomes, resource cost, and utility. It is one way to display an algorithm that only contains conditional control statement. Decision trees are commonly used in operating research, specifically in decision analysis, to help identify a strategy most likely to reach a goal. So when you want to reach a goal, you develop a decision tree. How to reach your goal? Using decision tree, but also a popular tool in machine learning. So in general, a decision tree, we make statements. A person wants to learn about decision tree. If it is true, then make a decision based on whether or not the statement is true or false. We make a decision whether the statement is true or false. So when a person, okay, there is a statement, a person wants to learn about decision trees. When it is true, check out this class. And when it is false, check out another. Check out the others. Maybe he want to see Justin Bieber. Okay, if it is true, then check out Justin Bieber videos. Yeah. So that's simple. A decision tree, when a person wants to learn about decision tree and check out this class, this is when a decision tree classifies things into categories. So there is into categories. That's why it is called classification tree. when a mouse eats a special diet, when it is true or false, it is between 150 and 180 millimeter long. Yeah, if it is special diet, yeah, the length of the mouse is around 150 to 180. If it is false, it is less than 150. So this is when the decision tree predict numerical values, it is called regression tree. We can also combine mix between classification and regression later on. There is also terminology in decision tree. There is the terminology are root node, internal node, and leaf node. Okay, so this is the decision tree on what kind of device that the customer should have. Should he has Microsoft or Chrome or Apple or this one and two, I forgot the name. So the first statement is, do you fear of technology? Fear the technology? If yes, true or false? If yes, okay, is your dad rich? If yes, buy iPhone. Yeah. If not, buy Chrome. If you are not fearing of technology, but do you care about privacy? If you do not care about privacy, go to the Microsoft. If you care about privacy, if you, do you have life? If you have life, this is by the open source. What is the open source meaning? The open source operating system. What is it? Sachin.
Linux.
Oh yeah, Linux. Yeah, Linux. Irwan, thank you. This is Linux. And if you don't have live, I forgot the name of this. Yeah, if you have live, go to Linux. So this is simple model of decision tree model. Yeah? What kind of product should you offer to your customer? Did he fear of technology? If yes, are you rich or not? If yes, iPhone. If not, Chrome. And then if you not fear of technology, but do you care about privacy? If yes, and do you have life? Go with like Linux. If not, go with something else. If you don't care about privacy, use Microsoft. So the very top of the tree is called root node. This one is the root node. Yeah. The top one is the root. And then for the one that is breaching, what we call it internal nodes or branches. Yeah. And then the final or the last is what we call leaf node or leaves. Yeah. Leaf node is the product that you should offer to the customer for the following the example before. Yeah. So this is the leaves. Yeah, that you are your class is the class is on the leaves. So how do you split? How do you select the decision tree splitting methods? So there are several ways. One of the ways is using the what we call Gini impurity. Gini impurity is a function that determines how well a decision tree was split. Basically, it helps us to determine which splitter is best. So we can build a pure decision tree. So pure decision tree is the one like this. This one. The final one is the pure one. This is what we call, oops. This is what we call pure. Yeah. And this one is impure because it is still mixed up between the one that is fear and not, the one that is rich and not, the one that is care about privacy and not. So this is still impurity. So the impurity is still high. And this one, the impurity is 0. You can call this also impurity equal to 0. This one impurity can be around until 1, up until 1, the impurity. Yeah. So on the leaves, supposedly the impurity is 0 all. Yeah. The genie denotes the purity. The genie denotes the purity, and hence genie impurity tell us about the impurity of the nodes. If the impurity is close more than 0 or more to 1, the node is still impure. But if it is 0, it is pure already. So the lower the genie impurity, we can safely infer the purity will be more and higher chance of homogeneity. So the one that is having 0 impurity, it has the homogeneity of the nodes.
Sorry,
Yes.
this impurity purity is what? Is the accuracy of the data or? Because impurity in science is like, it is the quality. Like say we are talking about an impure water, means the water contains some foreign elements, right?
Yes. So let's say like this. Okay. Fear of technology. 11 says yes, 10 says no. So it is still impure. Mix blood. Still mix the blood between the fear and not. And then your debt rich is yes. This one is 5 all rich. 6 and 6 is no. Yeah. So 5 all rich and 0 which is not rich. This is 6 is not rich, 0 is rich. So this is the impurity is 0 because all of them is rich. This one, all of them is not rich because
that is also pure data.
Pure data because the rich is 0, the not rich is 6. The rich is 5, the not rich is 0. So as long as you are the opposite is 0, meaning the impurity is 0. Already homogen. The homogeneity is high. Araso, Subendu.
Okay.
Yeah. So the higher the Gini impurity, sorry, the lower the Gini impurity, meaning the higher chances of the homogeneity of the nodes. So it helps us to find out the root node by finding the utmost lower impurity. Yeah. Intermediate nodes and leaf nodes to it helps us to find out the root node, the intermediate node, and the leaf node to develop the decision tree. It used by the chart classification and regression tree algorithm for the classification tree. It reaches its minimum 0 of the Gini impurity when all cases in the node fell into the single target, meaning all of them homogen, yeah, not hetero anymore. It's homogeneity within the nodes. All of them is rich. All of them is pure. All of them is happy. All of them is sad. So it means it reached its minimum. It reached its minimum of the zero impurity. So that is the end of the end of the terminal for that path, for the specific path. So this is the way on, this is the decision tree splitting methods using the Gini impurity. So let's say we have 10 coordinates of data. This one is blue, 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 blue. This one is red, 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 red. So the 1, 2, 3, 4, 5 is red. 1, 2, 3, 4, 5 is blue. 5 blue, 5 reds. Okay, oh no, green, yeah. 5 blue and 5 green. So on the left side, so if we have this line separating the two data, on the left side it is pure 0, yeah, because the Gini impurity is 1 minus the probability of blue, the number of blue compared to all of the point in the left side. So the blue is 4, all point is 4. So 1 minus 4 divided by 4 by the power of 2, yeah, equal to 0, meaning it is 0. The Gini impurity is 0. On the right side, there is 1 blue and 5 green. So there is hetero there. How to calculate the Gini impurity? The same like the above, 1 minus the p by the power of 2. All of p by the power of 2 minus. So 1 minus in the bracket of p of blue and p of green by the power of 2. So 1 minus 1 divided by 6. The blue is 6 by the power of 2 plus 5 divided by 6 by the power of 2. So we have the Gini impurity 0.278. So by this we understand the left side and the right side. But what about the average of Gini impurity for these two conditions? The average Gini impurity equal to total number of blue divided by total number of point times the Gini impurity plus total point on the right side divided by all point times the Gini impurity of the right side, 0.28, equal to 0.1668. So by this we understand the Gini impurity of the left, the Gini impurity of the right, and the average Gini impurity. So this is the way for us to calculate which one going first. Which one going first into the root node. So we compare the average. We are going, if we want to determine the root node, we need to determine the lowest average Gini impurity. The lowest average Gini impurity. Yeah. To identify the root node. What is the root node? The root node is this one, the top one, the starter one. That is the root node. Okay, let's calculate the Gini impurity with the another. So let's determine the root node using the other data. So we have this data like this. Okay. People love popcorn. Okay, we have 1, 2, 3, 4, 5, 6, 7. Okay, 2 is saying, is he saying yes, yes, no, no, yes, yes, no. Okay. And love soda, yes, no, yes, 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 no, etc. And less cool ice. Blah, blah, blah. So which one going into the roof node? Is it love popcorn first, love soda first, or love cool as ice first? So we need to identify the rooftop to build the classification tree. So we try with the popcorn first. Yeah. In when for the popcorn, the Gini impurity, when we have popcorn here and then cool as ice, when we love popcorn, and then if it is uh, if it is true, do they love cool as ice? Or if it is false, do they love cool as ice? So in the first stage, we identify loves cool as ice. When it is yes, 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 4 people. How many of the 4 yes saying yes to the love cool as ice? Only 1 yes. The other is no. 1 yes, 3 no. Okay. So what is the Gini impurity? The Gini impurity for the cool as ice is 1 minus 1 divided by 4 by the power of 2 minus 3 divided by 4 by the power of 2, we have 0.375 for the Gini impurity. What about false? When it is false, meaning no, no, not loving popcorn, 3 people, only 2 saying yes, love cool ice, 1 saying no on the cool ice. So the Gini impurity for the leaf is 1 minus 2 divided by 3 by the power of 2 minus 1 divided by 3 by the power of 2. We have Gini impurity 0.444. Yeah. And then what is the weighted average Gini impurity of the leaves? Is 4 divided by 7 times 0.375 plus 3 divided by 7 times 0.444, we have 0.405. This is for the cool as ice. So, for the popcorn, yeah, for the popcorn. Gini impurity for loaves popcorn is 0.405. Gini impurity for soda 0.214. Gini impurity for eggs 0.343. Which of these Gini impurity is the lowest one? The Gini impurity for the soda, the lowest one, meaning the higher probability for the homogeneity. Yeah, the lowest Gini impurity, the lowest Gini impurity. Yeah. So we decide love soda for the first root node. So soda is the first root node. Okay. So now that we understand the main idea on how to build and use classification tree, let's discuss one technical detail. So when people love soda, and the age is 15 less, then he will love cool as ice. So this is the decision tree that developed by using that by to develop this decision tree, we need to develop the Gini impurity. But this is the technical thing on how to develop this decision tree. But in the machine learning, the model will develop it. Yeah, the model itself will learn and develop the Gini impurity to develop the decision tree. So far, any question? Any questions? Araso? All right. After the Gini impurity, there is another option on how to split the decision tree by using the information gain. Information gain is the Gini impurity minus the average Gini impurity. Okay, this is the Gini impurity of the roof nodes, and then this is the average Gini impurity of the nodes. Yeah, the internal nodes. So we have the information gain is 0.51. So the difference between Gini impurity and information gain is in the Gini impurity we search for the lowest index, but for the information gain we search for the highest information index. So information gain we use also, the second alternative is using the information gain to do the splitting in the decision tree. Yeah. So let's see the example like this. There is color here. We have 1, 2, 3. 3 color, diameter 2 diameter, and label 3 label. Yeah. So the Gini impurity is 1 minus the apple by the power of 2, the grape by the power of 2, and the lemon by the power of 2. So 1 minus apple is 2 by 5 by the power of 2, plus grape 2 by 5 by the power of 2, and then lemon 1 by 5 by the power of 2. We have 0.63 in the gain impurity. So it's still mixed. Yeah? So after that, we develop the average Gini impurity, and then from the Gini impurity minus the average Gini impurity, so we sort the highest information gain to identify which nodes going into the roof node. So there is another way on doing it. So, but in the model, we are not doing it manually. So the model will create for us. So I am explaining you how the model works on splitting the trees. Okay, so far any question before we go to the demo? All good? Capish?
Judy,
Yes, Irwan.
can you explain about the entropy? Meaning, what is entropy?
Entropy, the other methods. The other methods on
So it's
splitting
different
the...
from information.
Come again, Irwan?
So it's different from information gain.
Okay. So there is 3 options there. Basically, I use the one is the gain Gini maturity. Number 2 is the information gain. Number 3 is the entropy. Okay. So the entropy, the entropy is the other methods to split the decision tree. Basically, I already have the module, but actually I just want to explain the two. But if you want to discuss on the entropy, okay, wait a second. File. Okay. Contoh nih. I use I explain with the Gini and information gain because the decision tree model using the scikit-learn using that methods, yeah, that I am doing for tonight class. But let's see, let me explain to you also about the entropy. Okay. Right. Okay. All right. This one. So, okay. Can you see the slide?
Yes.
Okay. The other method is using the entropy. Yeah. So entropy is the measure of randomness of the unpredictability in the dataset. Yeah. Information gain, the measure of decrease in the entropy after the dataset is split. Wait a second. Where is the entropy formula? Okay, this is the entropy formula. So in the entropy, the formula is the sigma of value times log times value. Yeah, more a little bit using log there. And then the formula is like this. So like a logistic, yeah. So we use log here. The entropy. So that's why I'm not using this for the Kegel, because it is slightly slightly difficult, because we use the log data, log, log, yeah. So to identify the 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 to split the nodes, we use the entropy, yeah, using the highest entropy to make the first split. So we use the entropy as well to develop the first split, the highest entropy. So but the calculation is a little bit more complicated because we use log data. Araso, Irwan.
Yeah.
All right.
So which method is the best one? Like
I use the Gini impurity mostly.
in empiric.
Yeah, Gini impurity, because this is more easy, yeah, more easy, and uh, the gain in the yeah, because it is more simple to understand, yeah, simpler to understand and interpret, rather than the entropy using log for every every single nodes, yeah. Araso, Irwan. So that's why
Yeah, so
I intend to explain for the simple one, the Gini impurity and information gain for the class, and also for the Kegel, using that kind of methods. Okay, capish?
thank you.
Okay. Next is, let's go into the Kegel. No, where's the Kegel? This one? Oh, this one kah? Oh, okay. Let's see. Not running kah? Wait a second. So this is the data. I get the data from the dataset in Kaggle, the healthcare dataset. Yeah. So we would like to see the likelihood of customer to get a stroke. Yeah. The likelihood of the customer to get the stroke. The decision tree towards the stroke condition. So we would like to check whether the patient is getting stroke. Let's say you are in a hospital industry. Yeah, so we would like to increase the what we call it. We would like to see the probability of customer getting stroke. So let's go import pandas SPD. Is it running yet? All right. And then read the data. Okay. 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 Basically in the financial, okay, basically the more people getting stroke, yeah. So let's say this is the financial data in the healthcare industry, in the hospital industry. Yeah. So this is the data of the patient getting strokes. So this is the data of the customer. the ID number of the customer, the gender, the age, the hypertension. Okay, wait a second. I get the data here, yeah. I just get the data from the Kaggle. So if you would like to see the data set, we can search the data set in the data set of the data set of the stroke. Yeah, not the data set. I mean the data set. Data set. Yeah. On home. The data set is in the okay. You can search in the data set, yeah, to see the stroke data. And then okay, this is the hypertension, the heart disease 10. So there is also discrete data, yes or no here, either merit, working type, the category here, resident type, yeah. So also the glucose level, BMI, mass index, smoking status, and the strokes. The customer getting stroke or not stroke. Yeah. So basically we need to encode the data. I want to change the male into 1 and 0. Male 1, female 0. Ever married? Yes, 1, no 0. Working type, private 1, self-employed 2, then resident type, urban 1, rural 0. Yeah. Smoke 1, never smoke, never smoke 5, formerly smoke 3, etc. Something like that. So we need to import the label encoder. So we need to encode the data. We import from the sklearn, we import the label encoder. So let's say I haven't shared it yet. So let me public. Okay. Okay, so from the sklearn pre-processing, we import the label encoder. And then I name it ENC. For the label encoder, ENC, encoder. So I would like to change the gender. I would like to encode of the gender using values. Yeah, convert the data into values from the text, from the string to values, numeric. Hypertension also change to values. Heart disease 10 already there. Ever married, yeah, change to values. Working type, change to values. Resident type, change to values. Smoking status, change to values. And BMI. Okay, let's do it. Okay, already kah? Okay, and then let's see the data. Okay, so you can see the data changes. So this is the use of the label encoder. So they can encode by the algorithm. The algorithm encode the data. So from the yes or no change to 111, no 0. Working type 1, 2, 3. Residence type urban and rural 1, 0. Glucose, BMI, smoking status 1, 2, 3. 1 is formerly smoke, never. 2, smoke 3. Yeah, smoke 3. So this is the new data after we do the label encoder. Let's check the data. Okay, this is the ID, the gender, the age, hypertension. Okay. So basically, I want to separate the data into dependent and independent data. So for the attribute data. Attribute data, the X data, the independent data. We need all data except the stroke. So the attribute data equal to data.drop columns of stroke. So we get, I want to have the 10 data only for the attribute data. Let's see let's run the model. And then, okay, so we drop the Y. The Y, the dependence variable is the stroke data. So I drop it. And then classification data is the stroke data. So classification data is the stroke data. Let's get the data. All right. So this is the classification data of the stroke data. Okay, so from the scikit-learn, I would like to import the train test split. So I split the data into training and testing to see the accuracy of the data. Okay. And then the scikit-learn, I would like to import the accuracy score to see the accuracy of the model, the confusion matrix, then the classification report. And from the scikit-learn tree, I import the decision tree classifier. So this is the tree importation from the scikit-learn model. Run. Okay. All right. So let's do some let's do the training data. Yeah. On the decision tree classifier. So all right. So we run the data, and then let's see the accuracy of the training and testing. The accuracy is around 90%. 90% of the data is accurate. The training model is there. And when the testing data when we do the model into the testing data, the accuracy is around 90%. So the model is there. So now we would like to see the decision tree visualization. From the scikit-learn tree, we import the export graph visualization. Yeah, to develop the tree data with the name of tree stroke dot, with the class name 1 and 0 for the stroke and not stroke. Yeah, we would like to see the visualization. Run the data, and then import graph visualization as figure source dot underscore graph. All right. So this is it. Okay, let me go to the right first. Okay. Oh, not a little bit to the right. To the right. Okay. Can we drag? Okay, can. Oh, plenty. Okay. So the model determine the root node, the internal node, the leaf node by using the decision tree classifier. Yeah, we already import the decision tree classifier from the scikit-learn. they conduct the splitting using the Gini impurity, for this one. So basically, let's say whether they are, the final one is class 1, class 0. Wait a second. Okay, where is the Gini impurity there? Okay. Okay, so are you within the age of below 66? Yeah, the population is around 2,500 with the value of 2004 to 6 and 1 to 6 with the class is 1. Yeah. Is it true or false? Class 1 is the stroke. Yeah. True or false? If true, it will see the age below 50. The sample is 2000 sample. This is the value. What is the BMI? Okay, going down again. See the BMI. Yeah. Is it the BMI lower than 413? Yeah. So the decision tree will gives you the decision modeling. Yeah. To see whether the customer or the patient will get the stroke or not. Yeah. So we go there, heart disease, blah blah blah. So it is go deep there, yeah, going deep to find to see the decision tree on this. So this is the way how to develop decision tree using Gini impurity. Any questions? Any questions on the decision tree? So far so good? Araso? Irwan? Any questions? Any doubt?
No, Pak.
Okay. What about the others? Bendu? Any doubt? Any questions?
Trying to digest, Pak.
Trying to digest. Okay. It will getting harder every week, yeah. Getting harder.
Iya, Pak.
Oh, why the result is so complex, Pak?
Yeah, I just following I just see the data, yeah, using the just using the data, and then the result is so complicated, yeah. So but that because the data is around how many data is there? Too much because of the attributes is very too much, yeah. The gender, the age, the hypertension, so many, yeah. So that's why the model becoming rigid like that, because so many attributes there. Yeah. But if it is only 3 attributes, 2 attributes, yeah, small, yeah, very easy to interpret. But this one is 10 attributes, so of course getting more and more complicated because we use many attributes there. All right, any questions? No questions?
Usually we have a question after we try it by ourselves, Pak.
Yes, you will.
After so many errors, Pak.
After so many errors. Okay, so this week is okay. Actually, we don't have any. Do you want to have another assignment before final test?
No, please no.
No, please, no.
So this one just for your perusal only, yeah. So for your eyes only, kah? Not for your codes. So next week will be the PCA, yeah, Principal Component Analysis. So this week is yes, Irwan.
What is the topic for final exam? Have you built the question or
For the final
topic?
exam, I am planning using PCA, yeah, Principal Component Analysis, but combining with the uh, combining with the
Oh, combination, Pak.
or combining the clustering with the market basket. So every cluster we do market basket. That is better off, yeah, I think. More complicated, yeah. So you develop the clustering first, and then every segment you conduct market basket. Do you see what I'm getting to? Finding the clustering segments and then developing market basket for each of the segment to see what is the uh, product combination that of interest of each segment. But that is still my idea. Maybe or another using PCA for the clustering. So PCA actually for this end of the week, yeah, weekend, yeah. So on the Sunday class, isn't it? Because last week I cancel the class, yeah, because I am on the trip to Sumatra. So we have another class this Sunday for the PCA or neural network, kah? I think PCA first. After it, then neural network. Yeah. So this weekend on Sunday we will meet again for the PCA class. Okay. All right. So far so good. Araso for the decision tree. Capish? All right. If capish, if pronto, then we have post test. Okay. Very quick, yeah. No worries. Okay. Let me stop the